Hello everybody, Harry from GMAT Ninja here, and welcome to the next episode in our GRE Quant series. In this episode, I'm going to be taking a look at functions and what we might call intimidating symbols. So what we're going to cover today is, first of all, what is a function? How do they work? How should you approach them? What's the algebra rules behind it so that you can answer a question about a function? We're also going to look at these symbol questions, those questions where they might give you, I don't know, something like a star or the @ symbol on your keyboard and say, this represents a new rule, go and apply the rule. So we'll look at how you can go and approach those questions. But really tying this together, we're aiming to get beyond this intimidation factor. Functions and these intimidating symbols, they're not any different from most of the other algebra questions you're going to see. They ask you to start the question in a different way, and a lot of the problems that some of our students have with them is just that freezing moment where they just look at the question and go, I don't know what to do with this. Once you get past that, once you get into the algebra, some of these questions are going to be okay, and hopefully you're going to see that as we work through today's video. All right, so today I've got 7 questions for you. We're going to start out nice and basic in the first question. Then I'm going to have a batch of questions that are about that kind of medium level. So if you're looking for something between 150 and 160, be nice if you could be able to get these. Like I say, the algebra is not that hard. It's just about understanding what the question's asking you to do. And then towards the end, I'm going to try and ramp the difficulty level up with the final couple of questions. But even those are not going to be too hard. If you're looking for something over a 165, you're probably already on top of everything we've got for you today. All right, so I'll get the first question up on the screen now. We'll give you a couple of minutes to take a look at it, and I'll see you back here to go through it in a second. All right, best of luck, and we'll see you soon. All right, as always in these videos, if you want a little more time to have a think about the problem, now's your chance to pause the video, but I'm going to take the question away. It's still up here on the board so that we can take a look at it together. All right, hopefully this is a nice, relatively easy intro question, except if you don't really know what a function is. So that's where we're going to start with today. So we're told this function, f, and that's just the name of the function. It could be any other letter. The function, F we normally use because function, the word starts with F, but could be F, could be G, could be H, could be I. It doesn't really matter. You could call it whatever you like. But we've got a named function f is defined by, and this is just a rule. And this rule says whatever input I want, in this case, the x is going to be the input, whatever I want to put into this function, I want to square it and then add 4. So a function is just a way of saying this is a rule that I want to apply to this input. And so in this question, when we're asked what's the value of f of 3, well, that just tells me that I want to use as my input the number 3. So in the original rule, whenever I had an x, I would square it and then add 4. So in my actual question, in the one I want to use, I'm going to take my input and square it and then add 4. And so in this case, 3 squared is going to be 9. And so my answer is going to be 13. The answer to this question is going to be E. So it doesn't matter what I use. Let's say -2. In this case, -2 is going to be the input. I put that into the rule, square it and add 4. I'd end up with 4 plus 4, I'd get 8. It doesn't matter what you change this to. this becomes the number inside the parentheses becomes the input, and I replace the x in the rule with what was inside the parentheses, and it doesn't have to be a number. F of p would be p squared plus 4. F of a plus b would be a plus b squared plus 4. Whatever's on the inside of those parentheses replaces the x in the rule, and then you just go and apply the rule. And so, yeah, when you're given a function, you said, what's the value of f of something? Go to the rule, replace the x value in the rule with whatever that something is, work out your answer, and you're there. So like I said in the introduction, functions, they look intimidating. They're just different from what you've dealt with before, likely, but the actual algebra behind them isn't that bad. And if we can get over this intimidation factor, hopefully you're going to be okay. All right, so yeah, straight away, we've had an introduction to functions. I'm now going to take the difficulty level up a little bit. We're going to have to be able to apply them. So I'll get the next question up on the screen, give you a couple of minutes. We'll see you back here soon. All right, pause here if you want any more time, but I'm going to take the question away so that we can take this one apart together. All right, so again, we've been given a function. In this case, f of x is 3 multiplied by x plus 4. Now, quantity A, yeah, okay, quantitative comparison question, which is bigger, A or B? Quantity A, I don't have to do anything with, it's just a number. Quantity B, on the other hand, well, this is a big step up from the last question. This doesn't look very nice, but as I said at the introduction, part of this video is all about getting over that intimidation factor. Let's just break this down and see where this question goes. So this is eventually going to turn into some number that I can compare against 24. So let's split this up because I've got two sets of inputs into my function here. So first of all, my rule. The rule that we started with, f of x is 3 times x plus 4. So first of all, if I just look at this f of p plus 28, like we said in the last question, whatever goes into those parentheses is just going to replace the x in the rule. So I can rewrite the formula, and wherever I see an x, now I'm just going to write p plus 28. So p plus 28 plus 4, and so we're going to have 3 times p plus 32, or 3p plus 96. Okay, there's the first half. I'll do the same thing with the second half here. So f of p plus 20. Again, rewrite the rule, but wherever there's an x, replace it with what's inside this set of parentheses here. So 3 times p plus 20 plus 4 is going to be 3 times p plus 24, or 3p plus 72. Right, so quantity A was, what do I get if I do f of p plus 28 and then subtract f of p plus 20? And so overall, quantity B is going to be, well, f of p plus 28 is 3p plus 96, and f of p plus 20 is 3p plus 72, being careful to stick that in parentheses because I've got the negative sign in between the two values of the function. So I've got 3p plus 96 minus 3p minus 72. The 3p's are going to cancel. The whole thing leaves me with 24. And so quantity A, 24, is exactly the same as quantity B. And so my answer to this question is going to be C. But so first question, we dealt with the rule. What is a function and just how do you get an input? This looks horrible. It looks much nastier, but it's exactly the same rule. This is my input. I put it into the rule. I'm going to get an answer. If I just work this through, take my time. Yeah, there's a bit of algebra here, but take your time, stay calm. I'm going to end up with something that cancels out and everything looks really nice. So we go from something intimidating and horrible. It's just the same as quantity A. So yeah, these functions, they look much worse than they are. All right, we're going to keep this going. We've got different ways that the GRE is going to ask you about functions. So staying in the same topic, but moving into a slightly different style of question. We'll get the next one up on the screen. Another couple of minutes. I'll see you back here soon. All right, pause now if you want a little more time to check this question out. But for now, I'm going to take it away so that we can work through this one together. All right, this is one of those questions where there could be lots and lots of work to do. If you go down the wrong path with this question, you're going to be doing algebra for pages and pages and pages. It's going to bury you. There's quite a lot to do here, but I want to be as efficient as possible. So first of all, what we're looking for is for which of the following functions does f of x equal negative f of minus x? Now, first thing to notice is this left-hand side, f of x, I have that. I don't have to do anything to calculate this. I only have to deal with one side of this problem. All right, there's other things we're going to do to speed this up as we move through the question. But for now, yeah, I only have to deal with one side of this. I only have to find f of minus x. Now, what I'm looking for is when does f of minus x equal, where does negative f of minus x equal f of x? Well, let's take the first one and see what that looks like in practice. So first of all, f of minus x, well, like we've done the last two questions, I'm just going to take the rule and replace x with minus x here. So negative x minus 1. So that's f of negative x. Now, does f of x equal minus 1 times this? Well, if I take f of minus x and multiply it by negative 1, I'm going to get x plus 1. Does that equal the f of x we had to begin with? No. And so A is not going to be an answer here. I can rule out A as an answer. And that's really what we've got to do here. We've just got to be as efficient as possible with how we go through this problem. And there's a couple of just not shortcuts, but just rules of thumb we can use in order to get that. And the first one's going to appear here. So f of negative x, again, I'm going to replace the x in the rule with negative x. But so I would end up doing negative x squared minus 1. But negative x squared, well, that's just x squared. So in this case, f of minus x equals f of x, which is not what we're looking for. We want the cases where f of x is equal to minus 1 times f of minus x. We don't want them when they're equal to each other, so we can cross out b as a possible answer. But this idea that an even-powered value is just going to equal x when I put negative x in, that's going to save us some time later on when we get down to the bottom here. And we can say the opposite. An odd power is going to be, if I put negative x in, is going to equal negative x. As the example here, if I put f of minus x into c, again, replace the x with what's inside the parentheses. In this case, we're going to end up with 1 over minus x, which is really the same as negative 1 over x. So our minus f of minus x is going to equal 1 over x, which is the same as the f of x we were looking for. So c's in. C is one of the answer choices we're looking for. F of x is equal to minus f of negative x. Right? Same thing with D. Like I said, there's no way around it. We have to do the work here. We've just got to be as efficient as possible. F of minus x, plug that into x, I'm going to get negative x times by, like we said earlier, x squared. If I put negative x into x squared, I just get x squared. And so this whole thing is minus 1 times what I started with, which is exactly what we're looking for. Minus 1 times what we started with will equal f of minus x. And so D, this is going to be one of the answers we're looking for as well. All right, last one. Got to put f of minus x in. X cubed, odd power. So that's going to be minus x cubed multiplied by 4 minus x squared, even power. So I just get what I started with. That doesn't change. And so again, I've got minus 1 times by what I started with. And so E does follow the rule that we were asked to find. And so E is one of our answer choices as well. All right, so in this case, there's no way around it. We're going to have to do some work here, but I don't want to do too much. I don't want to go too far. Like I said at the start, I have the left-hand side of this equation. I've just got to find the right-hand side. If it's an even power, when I put negative x in, I'm just going to get what I started with. If it's an odd power, I'm going to get minus 1 times what I started with. And that can simplify the process. Yes, I've got to do some algebra, but it doesn't have to get too hard or too long or too cumbersome. So in a question like this, you're aiming for efficiency. We can use these rules of thumb to reduce the amount of work we've got to do, but you kind of just got to do the work. All right. Right, so we've kind of looked at a lot of algebra variations of dealing with functions. We're going to get into a little bit of how they work when you start combining them with graphs graphically. The graph questions, they don't come up all that often, but it's very helpful if you know what's going on when they do. So I'm going to get this question up on the screen, give you a couple of minutes to take a look at it, and I'll see you back here to go through it soon. All right, pause now if you want more time to think about it, but let's take that away so that we can go through this. All right, so at this point, I'm going to go through an explanation of the rule, and then at the end of it, I'll just give you the rule. So if you're just looking to memorize something, which I don't really advise, but if that's all you're looking for, bear with me for a second. I'm gonna go through why the graph moves around as it does, and then we'll take a look at what's going on in this problem. All right, so the question told us that this diagram shows the graph of the function h of x. Right, so every function, in the same way that we could say for just about every equation, every function represents some sort of line. So this function h of x gives us a line, and this is the line that it gives. All right. Now, what we can say, I'm going to use some example numbers here. These are not necessarily they could be right, probably not, but these are just numbers I'm going to use for this explanation. Let's just say that that's 2 and that's 4. And so this function crosses the x-axis at 2 and 4. In other words, the y value, as you can see here, that's the y-axis is labeled h of x, and you can think, if you're thinking about graphs, you could think y equals is the same as hx. H of x equals the function h of x equals. So when my input is 2 and when my input is 4, then the output of that function, the value of that function, is 0. In other words, I can say something like h of 2 is equal to 0 and h of 4 is equal to 0. Now, I don't know what the function is. We're never going to be told in this question. But all I know is, again, I'm using these numbers arbitrarily just to make this example. But if I put 2 into the function, I'm going to get 0 out. And if I put 4 into the function, I'm going to get 0 out. So this is the function of h of x. And I want to look at h of x plus 5. All right. So I know that when what's inside the parentheses equals 2, the output will be 0. And when the input inside the parentheses is 4, well, the output will be 0 as well. So that doesn't change. I can look at this and say, well, if x plus 5, if that was equal to 2, then x is going to equal negative 3. And so when x is negative 3, then this graph will still go through the x-axis. Similarly, for this point, when x plus 5 is equal to 4, or when x equals negative 1, well, then the graph of h of x plus 5 will cut the x-axis. What happens when I add 5 is that the graph shifts left. And then now it cuts the x-axis at negative 3 and negative 1. And so the graph is going to look something like that, where if I extend that on, there's negative 3 and there's negative 1. And we can say a similar thing about quantity b, h of x minus 7. Well, again, when x minus 7 equals 2, my input to the function will still be 2. In other words, when x equals 9. So if I put x equals 9, then 9 minus 7 will give me 2. And I know that when I put 2 into the function h, I get 0. Well, then when x equals 9, the graph of h of x minus 7 will cross the x-axis. The same idea happens when x minus 7 equals 4 or when x equals 11. What would happen is that this graph will also cross the x-axis at 9 and 11. And so what we're seeing here is the graph moves left and right. Right, so that's a bit of an explanation about what's going on underneath it. The rule, the bit you need to know for the GRE, is when the change is inside the set of parentheses. So in this case, h of x plus 5, it's inside the brackets. Same over here, h of x minus 7, it's inside the parentheses. When you're in that scenario, the graph's going to move left and right. It's not going to shift up and down, it's just going left and right. And when it's x plus 5, so when you've got a positive number inside the parentheses, the graph is going to go left. And when you're subtracting, when there's a negative number, the graph's going to go right. It's not going to go up and down. It's not going to go left, or it's just going to go left and right. So the graph we were given, the diagram in the question, crossed the x-axis twice. Again, I don't know if it was 2 or 4. Those numbers were just picked arbitrarily to make a point. But because the graph crossed the x-axis twice, quantity A, all I did was shift that graph left, so it will still cross the x-axis twice. Quantity B, all I did was shift the graph right, so it's still going to cross the x-axis twice. So the number of times both quantity A and quantity B and the original graph all cross the x-axis is 2 times. So quantity A is the same as quantity B, and so the answer to this question is going to be C. But the big takeaway I want you to get from this question is when the change to the function is inside the parentheses, in this case plus 5, in this case minus 7, then the graph just shifts left and right. So however many times it crosses the x-axis, it's going to be the same. Just goes left and right. All right. Now something different will happen when the change is outside the parentheses, and we're going to get to that now. So I'll get the next question up on the screen, give you a little bit of time to take a look at this one, and I'll see you back here soon. Okay, pause things here if you want a little more time to have a think about this one. I'm now going to take that question away so that we can work through this problem. All right, so the eagle-eyed among you will have noticed that this time the change to the function was outside the parentheses. So last time we had the x plus 5 and the x minus 7, and both those changes, the plus 5 and the minus 7, were inside the sets of parentheses, and those made for horizontal changes. As you can probably, hopefully guess, this time we're outside. This time the changes are going to be vertical. Right. Now, the other difference is last time the plus 5 actually worked kind of almost opposite what you were expecting. Plus 5 and we moved left, minus 7 and we moved right. Whereas this time, the changes are going to work almost as you expect. So the positive number, in this case plus 8, positive number, we're going to move the graph up. We're going to move the graph up by 8 units, and we'll do that in a second. But the negative, if it was q of x minus 8, well, then we would move down. So when you're making vertical changes, they tend to work sort of as you'd expect. If we add 8, the graph goes up. If you subtract 8, the graph goes down. Whereas with horizontal changes, they almost work opposite. X plus 5, we moved left. X minus 7, we moved right. Right, but in this question, as I said, q of x plus 8. Now, I don't know anything about q of x other than it goes through this point A at -7, -5. Don't know what the slope is. Don't know what the y-intercept is, don't know what the x-intercept is, don't know anything about it other than it goes through this point. So all I can do with this is to take the graph and lift everything up by 8 units. So hopefully I can draw a line parallel to the original, or just imagine that it's parallel because I've never been able to draw straight lines very well. And then this point here is going to move vertically up by 8 units. Now it's moving vertically, so the x-coordinate is not going to change at all. The y-coordinate started at -5, and I'm going to be, sorry, I'll make that negative more clear. The y-coordinate started at -5. I'm going to move the graph up by 8, so I'm going to add 8 to that y-coordinate, and it's going to be at 3. So I'll just call that A with a dash there to show that it's the point A, but we've changed it, and I know that point is going to be on this line, q of x plus 8. The big bit to pay attention to in the question is this word must. Which of the sets of coordinates must lie on this line? And the only thing we know is at this point, -7, 3, the answer choice C, that's the one that must lie on the line. Right, few of you, don't know who, but few of you might have looked at A. And I just want to take a quick look at this to say why A is not the right answer here. C is the only answer choice that must be on the line. And that was all about because the only thing I know about q of x is it goes through A. I don't know the slope. If the slope of the line is 1, then A would be on the new line, the new raised line. But I don't know the slope. So just as an illustration for this, you do not need to do this if you were doing the question in the GRE, but as an illustration of what's going on here, this black line here, q of x, could be the line y equals x plus 2. But it could also be the line y equals 2x plus 9. So because the only thing I know about the line is this one point, I don't know any other points, I don't know a slope, I don't know an intercept, these two equations could be the black line here that we had that was q of x. All right. Now, to get to the blue line, this q of x plus 8, all we did was add 8. So I could add 8 there and add 8 there. And so the new equations would be y equals x plus 10 or y equals 2x plus 17. Right. Now, if I put the x value of -15 into this first equation, I'm going to get -15 plus 10, well, that's -5. So the point A would be on this new line if the black line was y equals x plus 2. But if I put -15 into the second one, well, then I'm going to get -15 times 2, -30, plus 17. I'm going to get -13. That's not the -5 that we were looking for. So this point A could be on the line q of x plus 8, but it doesn't have to be. And the way this question's worded, which are the following sets of the coordinates, must lie on the graph of q of x plus 8, A is not going to be an answer here. All right, so this question was all about taking this point A and raising it up 8 units in the y direction, which means that we know that this point -7, 3 is going to be on the line. It must be on the line of q of x plus 8. And that's why C is the right answer and A is not. So that little bit at the end, extra work, you would not need to do that if you were in the exam, if you were in the GRE. The point here is that when you're adding and subtracting outside of the parentheses, if it's a positive number, the entire graph goes up. If it's a negative number, the entire graph goes down. And so from that, we've covered left-right movements and up and down movements. All right, so that's the sorts of things the GRE will do when they're talking about functions graphically. Now I'm going to get into one of these questions where they just throw a new symbol at you. So give you a couple of minutes to see if you can interpret this question, and I'll see you back here to take a look at it very soon. All right, pause things now if you need more time to work on this one, but I'll take that away so that we can look at this question together. All right, so talked about at the beginning, intimidating symbols. Just they throw a symbol at you, entirely new operation, you've just got to work with it. And we've got that here. The operation star, whatever this star is, it just represents something, is defined as r star equals 1 over r plus 2. And we know that this works for all positive numbers r. So we've got a slight limitation on what we can put into this operation. Now, this is doing a very similar job to the functions. The r in this case is the input, and the star tells us we're applying a rule. You could rewrite this whole thing as f of r is 1 over r plus 2, and we'd end up in exactly the same point. So the star it's just another way of saying, I want you to apply a function. And so, as we said at the beginning, there's an intimidation factor to this. Yes, we've got a star in it. We just have to work with it. So as we said, we can represent this in the same way as a function. This r value, whatever we're given, that's an input. And in the rule, I will replace the r with whatever we are given as an input. All right. So into the question, quantitative comparison question, as we can see, don't have to do anything with B. This is all about quantity A. I've got 2/3 star star. All that means is I'm going to have to apply this rule twice. So I'm going to ignore the outside bit to begin with and just take a look at what do we get when I do 2/3 starred. Well, if I just follow this rule, if I replace the r with 2/3, I'm going to have 1 over 2/3 plus 2. Okay, dealing with fractions, 1 over 2/3 is the same as 3 over 2 plus 2. And we can simplify this, plus 4 over 2. So the whole thing's going to be 7 over 2. So 2/3 starred is 7 over 2. But what I want is 2/3 starred. So I need to go through this whole process again. So I need to put, so we could say 2/3 starred again. Well, the 2/3 starred on the inside, that's the same as 7 over 2. So I need to do 7 over 2 starred. And it's just a case of following the process once more. I've got my rule, 1 over r plus 2. Whatever's inside the brackets here, inside the parentheses, 7 over 2, that's what I'm going to replace the r with. So I'm going to have 1 over 7 over 2 plus 2. Again, flipping the fractions here, dealing with, I've got 1 over a fraction, so that's going to be the same as 2 over 7 plus 2, which is 2 over 7 plus 14 over 7, which is 16 over 7, which is greater than 2. So quantity A is bigger than B, and so my answer to this whole question will be A. All right, so the big bit about this was I'm giving you a new rule, giving you a new symbol, this star. It doesn't do anything that scary. The algebra here, the work you have to do, isn't that horrible. It just looks horrible when you first look at it. And if you can break it down and understand that all I'm doing here is exactly the same thing we've been doing with the functions, just giving you a new rule and asking you to apply it, you can work through the algebra. We get to an answer. 16 over 7 is greater than 2. I've got my answer there. All right, so that's one way of doing this question. There is a bit of a shorter way of looking at this question. And this is part of the strategy of quantitative comparison questions on the GRE. If you look at this, I've got something going on over here, and I've got a 2. Now, this question said for all positive numbers, the operation is defined as 1 over r plus 2. So whatever I put in this case it was 2/3, but whatever I put in, I'm going to add 2. And the 1 over r, because I can only put positive numbers in, the 1 over r must be positive. So I've got a positive number plus 2. So whatever I put into this function, it's gonna have to be bigger than 2. I can't put 0 in. I can't make 1 over r equal to 0. I can make r really big and make it very close to 0. But whatever I put into this function is going to be 2 before we even begin. So this algebra, if you can do it, if you can follow it, wonderful. But if you're looking for those top scores, if you're looking for the 165 pluses, hopefully you're looking at this start point of this question going, hang on a second. Whatever I put into that function is going to be bigger than 2, so I can very quickly get to A and I can use my time on other questions. All right, so there were several reasons why I wanted to throw this problem out there. The big one for most people is just, please don't be intimidated when they give you a new symbol. It just means we're going to give you a new rule to work with, and if you think the rule through, you can follow the process. All right, I've got one more question for you today. We're going to try as best we can to ramp the difficulty level up for you. I'll give you a couple of minutes to have a look at this one, and we'll see you back. All right, for the final time today, if you need a little more time to have a think about this question, now's your chance to pause it. I'm going to take it away so that we can look at it together. All right, so I'm doing a few new things with the functions here, but most of the extra difficulty in this question comes from the algebra. Now, this is up at the top end of what the GRE might ever ask you to do. So if you're aiming for anything up to a 160, please don't worry if this question really you really struggled with it. I mean, even if you're aiming up to something like a 165 or so, yeah, I can see you slipping up on this one. If you're 165 plus, even this one shouldn't be slowing you down too much, but yeah, we'll see where we end up to with this. All right, so like we said throughout the rest of the video, we've got a rule here. So I know f of x should equal x squared minus x. Now this time I'm giving you slightly different information. F of 3p equals 42. F of 3p, that is a a terrible 3. Let me try that again. F of 3p equals 42. Now that tells me whenever I put 3p into this rule, the output's going to be 42. So I can stretch things out a bit and say, well, okay, f of 3p, if I replace the x with 3p in this function, what I'm going to get is 3p squared minus 3p. That's f of 3p, putting 3p into the rule, but I've been told that that equals 42. So really the bit that I want to work with, if I'm going to find the value of p, the bit that I want to work with in this problem is going to be those two sides. Now I've got an equation that I can go and work with. Squaring those parentheses, I'm going to end up with 9p squared minus 3p equals 42. Everything here is divisible by 3, so I'll say 3p squared minus p equals 14, and I can pull everything to the left-hand side to give me that equation. Now, I've got a quadratic, and I'm going to go and factorize it in a second. This is up there with the hardest quadratic you're going to see on the GRE. It's rare that you're going to see something where the squared term has a coefficient, but it's possible. They could ask you to do it. Now, fortunately, in this case, 3 is a prime number, so the only options we've got for the start of the parentheses are going to be 3p and p. Now, because the 14 is a negative, I know one of them is going to be positive and one of them is going to be negative. And I know that when I expand these brackets back out, then the number of p's is going to be, what's going to be -1. All right. Now, numbers that multiply together to make 14, well, I've only really got 14 and 1 or 7 and 2. And if you work through the options here, the only way this is going to work out is if I've got a 7 there and a 2 there, and if that's negative and that's positive. Now, this video is all about the functions and how they work. So I'll leave you to play around with that quadratic if you need a bit more time to think about this one. Like I said, this is right up at the top end of the sort of quadratic the GRE might ever ask you to do. So if you're aiming for 160 up to 160 and that you didn't know where that went, I possibly wouldn't worry too much. This is all about the functions. This video is all about the functions. So if you were following as we work through this bit, that's the bit that I'm really worried about. Okay, last step here. I need to get to the answers. What happens if I make each of these brackets equal to 0? I can find a value for p, in which case one of them is going to be 7/3, and the other one's going to be -2. So looking through my answer choices for something that equals -2, A is going to be one of my answers. I need to indicate two such numbers. The other one's going to be 7/3. And so my answer to this question is going to be A and C. All right, so two different bits there. The first bit is the bit that I'm worried about for everyone in this video is hopefully you were comfortable with what I did with the functions, the different pieces of information I was given, and at least getting to the start of this equation. Now, the second half about going to solve that quadratic, that might have been more complicated. And like I said, that is about as hard a quadratic as the GRE is going to ask you to answer, but they could. So you should probably see it at least once. But if you can follow that, if you understand what I'm doing with the functions, and if we could, hopefully over the course of this video, we've got you over that intimidation factor and you understand that actually functions are they're just like algebra. They're just asking you for a different start point. If we get you over that intimidation factor, if you've understood what we're doing and how you input the information into the functions, yeah, hopefully you've got a couple of extra questions you can get right on your GRE. All right, I hope that's been helpful for everybody. Have a great day. We look forward to seeing you back here at another one of our videos very soon. Thank you very much, everybody. We'll see you soon.